So what was happening was that we had three. I mean, we did two types of hybridization. We had sp3. So all 4 electrons of carbon got pulled in 4 different directions. So the shapes of the orbitals became like this, and they were called sp3 hybrid orbitals. In sp2 hybridization, carbon was only bonded to 3 atoms. So 3 of its electrons got pulled or stretched in different directions. So the shape of the orbitals became like this. They were sp2 hybrid orbital, whereas the 4th electron remained unchanged, and that ended up forming pi bonds. So we did that, and the last one was sp hybridization, and this is what we're going to complete. What would happen in this is that in sp hybridization, what you had was just a second. I said so. One second. Nice. So this one. In sp hybridization, you had carbon is bonded to 2 atoms, just 2 atoms. These were the examples: carbon dioxide or HCN, or you had C2H2. Carbon would be making 2 sigma bonds, 2 pi bonds, or in other words, it would either be making 2 double bonds, or it might be making a triple bond and a single bond. So remember again that carbon has how many electrons? Carbon's got 4 electrons, right? Now, in this case, when it's bonded to just 2 atoms, carbon has 4 electrons, 2s1, 2px1, 2py1, and it's got another one which is 2pz1. So these are carbon's 4 electrons. Now, in this case, the thing that will happen is that carbon is going to be bonded to 2 atoms. So let's say it's 2 Auxin atoms, right? So 1 electron gets pulled in this direction, and carbon's other electron gets pulled in this direction. So that means only 2 of the electrons are getting pulled in 2 different directions. Whereas, so 2 electrons and their orbitals, they change shape. This one and this one. The shape is now different. One of them gets pulled in one direction, the other one gets pulled in the other direction. So let's imagine there are Auxin atoms that are pulling those electrons. So you've got an Auxin atom, you've got another Auxin atom. Carbon has 2 orbitals that remain unchanged. And those 2 orbitals are, one of them is 2py. So let's say this over here is the 2py electron. And it also has, and let me, so that's your 2py. And at the same time, it also has a 2pz orbital as well. The 2pz orbital would be on the z-axis. So let's say that's your z-axis. So there's going to be another orbital, and that orbital would lie on the z-axis, right? So this is how the carbon atom would look like 2 atoms, because there are only 2 atoms around carbon. So 2 atoms, because of the 2 atoms, 1 electron gets pulled in this direction, 1 electron gets pulled in this direction, while 2 of the orbitals of carbon, they kind of remain unchanged. Nothing happens to them. They remain exactly the way they were before. It's 2py and 2pz. Is this clear? Is this thing clear?
सर
हाँ जी.
सर ये सी डबल बॉन्ड ओ के साथ एग्जांपल दे रहे हैं आप?
हाँ, और मैं बताता भी हूँ. I'll explain how serial bond would happen. So the first basic idea is that carbon is only bonded to 2 atoms, right? So one of the electron gets pulled in one direction, the other electron gets pulled in the other direction. So no one is attracting these 2 electrons. So these 2 electrons remain wherever they were. I mean, you've got a 2py, you've got a 2pz. Is that clear? Saro, clear? Aisha, is this clear? Safa, is this clear?
सर
हाँ जी.
सर तो जो 2 एटम्स होंगे वो तो अट्रैक्ट नहीं होंगे, क्योंकि 2 एटम्स ये इनके साथ 2 ऑर्बिटल जो होंगे वो मतलब अट्रैक्ट नहीं होंगे क्योंकि 2 एटम्स है, तो इसका मतलब 2 पाई वो बॉन्ड बनाएंगे.
हाँ, तो अब 2 पाई बॉन्ड्स बनाएंगे, क्योंकि ये भी पैरेलल में आ जाएगा, ये भी पैरेलल में आ जाएगा. सो आई एम गोइंग टू डू दैट नाउ. So this is the next part. I'm going to bring in the Auxin atoms now. Okay, so remember carbon would look like this. So I'm going to bring in the Auxin atom now. Oxygen, so oxygen has 1s2, 2s2, and it's got 2p4, right? So it's 2px2, 2py1, and there's a 2p z1, right? So that means Auxin has, so that means Auxin has two orbitals, right? So I'm going to bring in Auxin now. Just 1 second. My board नहीं काम कर रहा, 1 second को. ठीक है. अच्छा, so I'm going to bring in Auxin now. So Auxin kind of has the same orbitals. I'm just going to copy this. Auxin has a 2py. It also has a 2pz. अच्छा, in arrows को मैं हटा रहा हूँ. In arrows की जगह ना, I'm going to draw the sp2 hybrid orbitals. Right? So that's one of your sp2 hybrid orbitals. That's the, sorry, चला गया. अच्छा, that's the other one. ठीक है. तो ये दोनों इसके sp2 hybrid orbitals हैं. They are getting pulled by two different atoms in these two directions. Okay, those are the sp2 hybrid orbitals. So I'm going to bring in the Auxin now. So Auxin is going to look like this. Okay, the Auxin will have a 2py. So that's the nucleus in the center. So that's one of the orbitals. So it's got two orbitals, 2py and 2pz. We can orient them in any direction we want. And it also has simultaneously a 2pz. So let's bring in this Auxin. Remember, Auxin needs electrons in these two orbitals. Ye bhi clear? Is this clear to everyone? Afin clear? Amna, is this clear? Tanya, is this clear?
So,
Yes.
Yes, sir.
जो कार्बन है उसके लेफ्ट पर भी एक ऑक्सीजन होगा ना.
There's going to be another Auxin on that side as well. I'm going to bring that Auxin later. So the first thing is, remember, carbon has 4 electrons, 1 electron getting pulled in this direction. So who's pulling that? It's Auxin that's pulling that. Auxin needs electrons in the 2py and the 2pz. Firstly, there's going to be an end-to-end overlap, right? So the two orbitals would overlap end-to-end. So that's your Auxin coming in. And the two atoms would start to overlap. So there's going to be overlapping happening here, right? And this bond over here, this orbital over here would shrink in size. The reason it will shrink in size is because the electron got pulled by that carbon atom. So that's one sigma bond, right? And then there's going to be another Auxin atom, and that Auxin atom would be coming from the left side. So that Auxin atom would be coming from the left side, and that Auxin atom will have the exact same situation. It's going to have two p orbitals that need electrons. So that's one of them. And there's going to be another one. And this time I'm going to arrange this Auxin atom in this way, that the other p orbital is on the z-axis. So it's got two orbitals. One of them is on the z-axis, and one of them is facing that carbon atom. Okay, so imagine, remember, it's got two p orbitals. I can arrange those p orbitals in any direction I want. The axes are arbitrary. So this Auxin is kind of slightly flatter. Now this Auxin will come in, and it's also going to overlap end to end. So they're going to start overlapping here. So one of the p orbitals would overlap, and these would overlap in the middle, and this orbital on the p orbital, the other lobe of the p orbital would shrink in size. So that is what will happen. Okay, so is this clear? So I'm just going to quickly go through what has just happened. Remember, carbon has 4 electrons. So one electron got pulled by one of the oxygen atom to the right side, and one of the carbon's electron got pulled by the oxygen atom that's on the left side. So they ended up forming sigma bonds. So this oxygen atom, one of its orbital ended up overlapping with carbon's orbital, and they ended up forming sigma bonds. This oxygen atom, the exact same thing happened. Now you're left with the remaining orbitals. First thing, the red ones. What would the red ones do? क्या होगा? What type of bond would they form?
Pi bond.
Okay, so they would form pi bonds. So there's going to be overlapping that will be happening over here and at the bottom. So there's going to be overlapping that will be taking place. So that's a double bond now, right? And then what about the green ones on the z-axis? This other oxygen atom is oriented in a different way because I wanted to have the p orbital parallel to this one. So this oxygen atom over here, its green orbital would overlap with the green orbital of the carbon atom, and they would also form a pi bond. And the pi bond would be coming out of the screen and going behind that. It's going to be behind the molecule and overlapping behind it as well. Right? Is this clear?
Yes, sir.
So again, remember, no one is going to ask you to draw this. They just want you to have a basic understanding of what it would look like. And even the drawing part is kind of really, really easy. The only thing, I mean, for SP, drawings are out of the question because I mean you can't draw this. I mean, most people can't draw this. So you're never going to get a question on drawing this. The only thing at best they're going to ask you about this is, so we're going to keep things simple. The only thing at best they're going to ask you about this is to identify whether it's SP hybridized or not. That's pretty much about it. And they're going to ask you about the angles as well. So it's going to be 180 degrees and it's going to be linear. Like one of the oxygen atom would be on the right side, the other one would be on the exact left side. It's going to be exactly opposite to it. So the angle that they're going to make is going to be 180 degrees. So pretty much that's about it. No drawings would be involved. Or at best, they might ask you to draw just one sigma, one pi bond. That's about it. So just remember, so I'm just going to redraw the carbon atom in the middle. So the carbon atom, just very, very quickly, maybe I can just find a picture instead of drawing this. SP hybridized carbon. So if we can have a better picture. So that is sufficient. So I'll just copy this 1 second. Because that's what the carbon atom would look like. And just to highlight that, again, one electron getting pulled by one of the atoms over here, the other electron getting pulled by the other atom over here. And the two unchanged p orbitals, they would end up forming pi bonds. One would overlap with this, I mean, with whatever is on the right side. The other would overlap with whatever is on the left side. And it might also form a triple bond. Like, I mean, the green one can also overlap with the one on the right side. So you don't have to go into a lot of detail with this. Just remember the angles. And at best, what they can ask you about is, I did previously state, so they might ask you, like, for example, let's talk about this molecule, right? So the questions could be something like this. They might ask you which orbitals are overlapping to form this, and let me keep this molecule next to the sp2 hybridized. So this one. So they would ask you which orbitals are overlapping over here. So it's basically the sp hybrid orbital, which is getting pulled over here. That's overlapping with hydrogen's s orbital. So this over here is, I mean, the sigma bond over here is going to be formed by the S and the sp overlap. Is that clear? बाकियों is
सर
हाँ जी
सर क्या आपने इसका क्या कहा था?
देखो ये था ना, कार्बन का एक इलेक्ट्रॉन इधर जा रहा है, एक इलेक्ट्रॉन इधर जा रहा है, ठीक है, और बाकी दो अनचेंज्ड है ना, वो फिर पाई बॉन्डिंग कर रहे हैं ना, राइट? Carbon is only bonded
यस
to two
सर
atoms. So वो कह रहा है कि the question is what type of overlapping is happening here? Well, it's a sigma bond, लेकिन between which orbitals? So hydrogen has an s orbital, carbon का कौन सा है? It's the sp hybrid orbital. Is that clear?
यस सर
अच्छा, and the same thing happens over here कि यहाँ पे किसकी overlapping हो रही है? It's who's forming the sigma bond? The sigma bond, like there are two pi bonds, but the sigma bond is the sp hybrid carbon atom orbital overlapping with nitrogen के अंदर p orbital होता है, so it's overlapping with nitrogen's p orbital. So they're forming, and who's forming the pi bonds? The pi bonds तो है वो, they are always formed when a p and p overlap. And there are two of them. ठीक है, the pi bonds are always formed when a p orbital overlaps with another atom's p orbital. ठीक है? So that's pretty much it. So no one is going to ask you about the drawing. They might ask you about simple drawings, which we have already discussed. Okay, we had already previously discussed. You might get simple questions like this one. Okay, show the pi bond in HCN. So you have an HCN molecule, you know the pi bond is over here, so show the pi bond, just draw it, that's it, just sketch it. That's about it. So the questions are going to be kind of simple. So just very quickly, let's go over this once more. Okay, you've got sp3 hybridized. So it's bonded to 4 atoms and electrons are getting pulled in all sorts of different directions. The other one is sp2 hybridized. When carbon is bonded to 3 atoms, it's making one pi bond, it's got one p orbital. And the last one is you've got carbon that's only bonded to 2 atoms. So the electrons are getting pulled, 2 of the electrons are getting pulled in 2 different directions, where the other 2 they kind of remain unchanged. So is this clear? Do you get this point? Do you get this? Is this clear or not? Yes or no?
Yes, sir.
And I'm going to extend this to other atoms as well. Let me just quickly extend this to other atoms. Now you have to stick to carbon, but they might ask you, they usually don't. I mean, usually it's just carbon, you just stick to carbon. But they did ask you one question about Auxin and nitrogen as well. So remember this. If I extend it to carbon, nitrogen, and oxygen, right? So I'm going to extend the hybridization to all of them. So how do you know which atom is and when is it sp hybridized, when is it sp2, when is it sp3? So if you want a more general sort of rule, that rule is if you have no pi bonds, so I'm extending it to other atoms. If no pi bonds, basically no double bonds. then it's very likely to be, so it's very likely to be sp3. It's pretty hard to make a general rule for hybridization and extend it to all other atoms. It's kind of really hard. Most of these rules are not going to function properly. So you're going to stick to carbon, that's about it. But if they might ask you about nitrogen or oxygen, if no pi bonds, that's sp3. If you have one pi bond, then that's going to be sp2. And if the atom is making two pi bonds, then it's going to be sp. So you can kind of extend this to nitrogen and oxygen. I'm not going to explain the same thing about nitrogen and oxygen because that's going to consume a lot of time, and this topic is not that important overall. It's a very minor topic. Very few basic questions come on this. So let me give you an example. I have an HCN molecule. Now forget carbon, just apply the rule. What sort of hybridization does nitrogen have? We did talk about carbon. Carbon is obviously sp hybridized. What sort of hybridization does nitrogen have according to this rule? How many pi bonds is it making?
2.
So it's making two pi bonds. So this one is sp hybridization. And you can apply the same rule to carbon as well. Like carbon over here is also making two pi bonds on this side. So that's also sp hybridized. What about, let's do another molecule. Let's say I've got carbon making a double bond, and there's H, and there's H, and there's N, and there's another H. Amrita, based on this rule, what type of hybridization does nitrogen have? How many pi bonds is it making?
1.
This is sp. This is going to be sp2 hybridized, right? And then you can apply the same rule to carbon. How many pi bonds is it making? That's also one, right? So that means it is sp2 hybridized. So just remember, I'm not going to go into the details of any other atoms hybridization. It's not that important. You just follow that rule. The whole thing that we did for carbon, it kind of applies to other elements as well. But you can just apply this rule blindly to the other atoms. Is that clear?
सर
Hanji.
सर आपने यही जो किया है आपने यहाँ पे ये आपने पीछे एक्सप्लेन किया था
कौन सा?
जहाँ पे आपके पास नो पाई बॉन्ड्स वन पाई बॉन्ड टू पाई बॉन्ड जो हमारे पास sp3 sp2
हाँ,
sp2 नहीं था
मैंने कार्बन को एक्सप्लेन किया था, लेकिन मैंने कहा था इसको आप एक्सटेंड कर सकते हो, नाइट्रोजन, ऑक्सीजन एक्सेट्रा, यू कैन अप्लाई टू अदर एटम्स एज वेल. ठीक है, but the detail is not important. Okay, don't go into the detail. They're not going to ask you a very big question on this, so there's no point wasting time on this. We just wasted time on carbon's hybridization. Even that was a waste of time because you're not going to get very big questions on this. Is that clear?
yes sir
So I'm just going to try and do some questions related to. I'll just maybe I have the worksheet. So about hybridization, and कहाँ है ये? So just remember, hybridization is a big concept. It's a very big concept. And जो भी हमने किया ना, we did it very, very briefly. And it's not that important, okay, to begin with. At least when it comes to A levels. So I'm just going to, so don't spend a lot of time on this. Where's segment hybridization? Yes. अच्छा चलो ये कर लेते हैं. So he's saying, so we'll do sigma and pi bonds and we'll do hybridization. Let me just quickly go over hybridization questions. Most of them about sigma and pi bonds. Even the sigma and pi bond topic, I mean, it's a very in-depth, detailed topic, but the questions are going to be kind of really, really simple. So for example, I mean, let's try and do all of them. बीच में ना वो भी आ जाएंगे hybridization वाले भी. So I've got an N2 molecule, so N triple bond N. So first thing, so can you tell me what hybridization is this quickly?
SP.
SP, because it's making two pi bonds, right? So this one is SP because you're making, I mean, the two pi bonds. इससे ज़्यादा वो नहीं पूछने वाले, वो drawings वगैरह, that's not important. As anyways, is it going to have three pi bonds? It's obviously not going to have three pi bonds because one of them is going to be the first bond is always a sigma bond. So the first thing is wrong. Three shared pair of electrons, that's true. A triple bond is three shared pair of electrons. And does it have two lone pairs? Nitrogen does have, it's got 5 electrons. So only 3 of them are bonding. So that means it's going to have 2 electrons. This other one would also have 2 electrons. So there would be 2 lone pairs of electrons. So we did questions like these earlier.
Sir,
Hanji.
sir, ये two lone pairs ये वाला explain कर दें.
Nitrogen के पास, it's in group 5, right? So it's got 5 electrons, right? So
Yeah.
out of 5, how many are bonding? 3 of them, right? 3 bonds bond, right?
Yes.
So out of 5 electrons, 3 are bonding, so 2 electrons are left. Is that clear?
Yes, sir.
Or uska bhi wahi hai, it's got 2 electrons. So that's one pair of electrons, that's a lone pair. The electrons that are completely full outer orbitals or pairs of electrons in the outer shell that are not bonding, those are your lone pairs. So it's got 2 lone pairs. So anyways, this question is about hybridization, right? He's talking about an ethene molecule. So ethene is this one. Double bond. What type of hybridization will it have?
SP2.
It's going to have sp2 because वही जो rule है कि if you have कहाँ गया हमारा rule? पेज किधर चला गया? अच्छा, if you have one pi bond, that's sp2. So this one has one pi bond. So basically, carbon kind of looks like this. Carbon looks like this. That 3 of the electrons are bonding in the normal way. They're sp2 hybrid orbitals, and there's an unchanged p orbital, and they're going to overlap, right? So who's forming the pi bonds? The pi bonds are getting formed by the overlapping of p orbitals. So ठीक है, और ये बीच में जो sigma bond बन रहा है between the carbon atoms, between the two carbon atoms, which two orbitals are overlapping?
Carbon.
P.
sp2. मैं actual drawing दिखा देता हूँ. The actual drawing of ethene looks like this. ठीक है. So this is carbon. One carbon has sp2 hybrid, sp2 hybrid, sp2 hybrid orbitals. So यहाँ पे there's overlapping with hydrogen, that's NS overlapping with sp2, NS overlapping with sp2. इधर बीच में जो हो रहा है ना वो sp2 और sp2 overlap कर रहे हैं, the two carbon atoms. Is this clear? ये मैंने highlight भी किया था इसके ऊपर. You get a lot of questions on this, right? So is this clear?
Yes, sir. So
Yes,
ऐसे नहीं
sir.
बोल सकते ना कि PP वो SP2 बोलना होगा हमें.
नहीं
क्योंकि
क्योंकि
वो भी हाइब्रिडाइज हो गया.
वो हाइब्रिडाइज हो गया ना, तो sp2 इसका sp2 के साथ होगा. ये pp overlap कर रहे हैं. The pi bond is formed when a p and p overlap. Pi bonds are always formed when a p and p overlap. मतलब pi bond का तो मतलब डाउट ही कोई नहीं है, उसका तो बस याद कर लो कि whenever they ask you about who's overlapping to form the pi bond, it's always going to be a p and p overlap. So the answer for this one is going to be A. कि between the two carbon atoms, the sigma bond is formed when an sp2 of one carbon atom overlaps with the sp2 of the other one. Just so next is हाँ ये बता दो which molecule contains a nitrogen atom with sp hybridized orbitals. Nitrogen atom. First one, I'm going to draw this one, CH3, CH2, and there's NH2, right? So this one, is it, what type of hybridization would this have?
sp3.
sp3.
ठीक है, sp3. अच्छा, what about HCN? Triple bond, 2 pi bonds. What hybridization?
So sp.
ठीक है, that's going to be sp. This is going to be sp3. तुझसे वही पूछा था sp किसकी है, तो वो इसी की है. NH3 में कौन सी, what hybridization in NH3?
sp3.
sp3. No pi bonds, so that's, वो फिर से कहाँ चला गया rule? So no pi bonds, that's sp3. Just a second. So now the next thing is, let me forget this. So what is always involved in a carbon-carbon pi bond? Obviously a shared pair of electrons. Whenever you have a pi bond, it's always a sideways overlap of p orbitals, and not always delocalized electrons, not always. Remember, we did discuss delocalized electrons. When carbon forms a pi bond, there was वो एक scenario था where there was delocalized electrons. Graphite, ठीक है? So only in graphite, that when you have too many p orbitals, each carbon atom is sp2 hybridized, only then there would be delocalized electrons, because the overlapping would happen and all of them would end up overlapping with each other. So the pi bond would kind of become delocalized. You wouldn't know whether this one is overlapping with this one or is this orbital overlapping with this one. So you don't know where the electrons are. So the pi bond is constantly switching around. So हाँ जी.
सर तो इसका मतलब पाई बॉन्ड के अंदर जरूरी नहीं है कि हमेशा डीलोकलाइज्ड इलेक्ट्रॉन्स हो.
नहीं होगा ना कि इथीन के मॉलिक्यूल में इलेक्ट्रॉन्स तो डीलोकलाइज नहीं है, वो तो यहाँ पे है और यहाँ पे है, राइट? कहीं और तो नहीं जा रहे ना?
यस सर.
लेकिन इधर जा रहे हैं, ये जो ग्राफाइट है ना, दैट इज वेयर यू विल हैव डीलोकलाइज्ड इलेक्ट्रॉन्स, बिकॉज दिस ऑर्बिटल कैन ओवरलैप with this orbital over here. This orbital can also overlap with this one. So you don't know where they are. You don't know, okay, is the overlapping happening over here, or is the overlapping happening over here? Yeah, is this overlapping with this one? So you don't know where the electrons are. Is that clear?
Yes sir.
So only in graphite will you have delocalized electrons. ये तो पहले किया था. Is there any, अच्छा, counting sigma and pi bonds? I wanted to see, एक दो और देख लेते हैं वैसे जल्दी से, के एक तो ये Bing Google के, एक सेकेंड. अच्छा, hybridization 9701. I had a worksheet, I don't know where it went. Just
सर.
हाँ जी.
सर ये टॉपिक बाकी है या लाइक इसके अंदर टॉपिक सभी में?
नहीं, केमिकल बॉन्डिंग तो हो गया, उसका कोई इशू नहीं है. अच्छा, I'll just
नहीं सर, इसके अंदर जो पार्शियल शेयरिंग होती है इलेक्ट्रॉन्स की, वो मतलब वो इस टॉपिक के अंदर आती है या किसी और के अंदर?
पार्शियल शेयरिंग कौन सी?
नहीं जिसके अंदर लाइक पता नहीं डाइपोल्स होते हैं सच या
चार्ज.
अच्छा, वो डाइपोल्स, वो तो इंटरमॉलिक्यूलर फोर्सेस है, वो हम करते हैं अभी, ठीक है. अच्छा, मैं खाली वो दिखा रहा हूँ कि लेटेस्ट कोई ना क्वेश्चंस कहीं आया. हाइब्रिडाइजेशन ये तो आया, ठीक है. इसके बस लेटेस्ट ये नहीं, इतना भी लेटेस्ट नहीं है. अच्छा, ये आप लोगों का ही है कि नहीं है? अच्छा हाँ, आप लोगों का. अच्छा, ये वाला वो कह रहा है कि the question is P and Q each contain an Auxin atom bonded directly to a carbon atom that is sp2 hybridized. Although it's an organic question, क्या मतलब है इसका कि sp2 hybridized के it's a carbon atom that is sp2 hybridized. तो आपको पता होना चाहिए कि this carbon atom would kind of look like this. How would it look like? it's going to be making a double bond. एक double bond बना रहा होगा, एक pi bond होगा. Is that clear? I mean, only this part. मतलब ये clear है कि if they say कि carbon is sp2 hybridized, right? So that means that carbon would be making at least one double bond. Is that clear? मतलब एक pi bond
Yes,
होगा.
sir.
ठीक है. मतलब ऑर्गेनिक के साथ उनको उसको लिंक किया है. तो remember, the hybridization part is not that important, but it can be very critically important, especially अगर वो बीच में ना, the key point is about hybridization. Like you wouldn't be able to solve this entire organic question if you did not understand this. Although इसके ऊपर directly the marks are not, I mean there's no direct marks on this. But without understanding hybridization, you won't be able to solve the entire organic question, especially for this one. Or इधर भी वो कह रहा है कि R contains an oxygen atom bonded directly to a carbon that is sp3 hybridized. What type of carbon atom is this? The one that is not making any pi bonds, मतलब वो single bonds बना रहा है, ठीक है? Is that clear?
Yes, sir.
So remember कि
Sir?
हाँ,
सर ये ऑक्सीजन के साथ आके sp2 हाइब्रिडाइज बना रहा है या पहले से sp2 हाइब्रिडाइज था कार्बन एटम?
नहीं उसने कहा कि मतलब मैं तो पूरे क्वेश्चन को तो नहीं देख रहा, मैं तो बस ये कह रहा हूँ कि उसने कहा कि ऑक्सीजन एटम बॉन्डेड टू कार्बन, तो वो जो कार्बन है ना, दैट इज sp2 हाइब्रिडाइज्ड. इसका मतलब है कि दैट कार्बन इज मेकिंग एटलीस्ट वन पाई बॉन्ड. इज दैट क्लियर? इट्स मेकिंग अ डबल बॉन्ड. अब
Yes,
ये
sir.
नहीं पता कि वो ऑक्सीजन के साथ बना रहे हैं या किसी और के साथ बना रहे हैं. वो कह रहा है कि ऑक्सीजन जो है ना, इट्स बॉन्डेड टू अ कार्बन एटम दैट्स मेकिंग, that is sp2 hybridized, and it's making a double bond. So maybe the carbon atom is bonded, making a double bond with oxygen. Maybe it's bonded to that oxygen, but it's making a double bond with someone else. Clear है?
Yes, sir.
मॉलिक्यूलर फार्मूला डिफरेंट हो सकता है पर मतलब सेम हो सकता है पर इनकी बॉन्डिंग डिफरेंट हो सकती है.
हाँ मतलब मैं वैसे इसको एक तो ये लिखा नहीं, जस्ट अ सेकंड, लेट मी एनोटेट, एक सेकंड. इसका मतलब ये मैं वैसे ही एक्सप्लेन कर रहा हूँ. Although the question is about organic, what that means is कि carbon is bonded to an oxygen. ये हमें पता है, मतलब इंफॉर्मेशन यही दे रहा है ना. That is sp2 hybridized. इसका मतलब है कि एक ना एक पाई बॉन्ड तो बना रहा होगा, 120 डिग्रीज एंगल होगा, ये बाकी यहाँ पे कोई x होगा, there might be a y, and I don't know कि वो जो p ऑर्बिटल है ना, वो किसके साथ ओवरलैप कर रहा है, वो x के साथ कर रहा है, y के साथ कर रहा है, o के साथ कर रहा है. So I'm not sure कि where that double bond is, but I know there is a double bond. Maybe the double bond is over here. Yeah, maybe the double bond is with Auxin, or maybe the double bond is between Y. Is that clear? You clear it?
Yes, sir.
Yes, sir.
And then you also have an Auxin atom, the other one. You also have an Auxin atom bonded directly to a carbon atom that is sp3 hybridized. So you have another Auxin atom that is bonded to a carbon atom that is sp3 hybridized. That means that carbon atom would be tetrahedral. It's making single bonds with, I don't know what, with XYZ, I don't know. So it's not making any double bonds. So remember, I mean, in this case, in this specific question, although there is no direct marks for sp3 or sp2 hybridization, but the whole question kind of depends on it. You don't know this, you're not able to solve this question. I mean, it's an entire question. और काफी
जो
marks.
मतलब जो आपने sp2 वाला बताया उसमें जो ऑक्सीजन है वो मतलब एक सिग्मा बॉन्ड भी बना सकता है और पाई भी बना सकता है.
हाँ मतलब कार्बन तो डेफिनेटली पाई बॉन्ड बना रहा है, ठीक है. ये नहीं
सर
पता
वो नहीं पता
कि वो
जी
किसके साथ बना
किसके
रहा है,
साथ.
ठीक है.
सर लेकिन वो ठीक है वो कार्बन के साथ भी बना सकते हैं क्योंकि 3 कार्बन है.
हाँ अच्छा, ये इसमें the other one, ये आ गया hybridization. So बस इसमें he's just asking कि what hybridization is this? Which one is this? One pi bond, that's
सर sp2.
sp2, ठीक है, बस ये. चलो ठीक है. तो remember कि direct questions are you not really that I mean it, this thing can become very critical for answering the question, and a lot of times you'll just get very basic questions like this, just 1 mark question. Like in that previous question, this thing was very critical. Like if you didn't know that, you wouldn't be able to solve the whole organic question. तो इसलिए it's better to, और एंड में ना आई थिंक द मोस्ट इम्पोर्टेंट थिंग इज ये एंड वाली चीज, मतलब वो ड्राइंग्स वगैरह भी बनी जाएंगी, ड्राइंग्स हर दफा बेसिक ही मांगता है, बट द इम्पोर्टेंट थिंग इज टू रियलाइज when is it sp3, when is it sp2, when is it sp, ठीक है? चलो ठीक है, लेट्स कंटिन्यू टुमारो. Okay everyone, take care, love is